Okay, in this lesson, we're going to be talking about linear inequality still. And a reminder that an inequality, the inequalities mean the not equal. So that's your greater than, your less than, greater than or equal to, less than or equal to. It says a linear inequality is similar to a linear equation. However, with an inequality symbol instead. So we remember graphing y equals mx plus b, so it's very similar to that. So first off, let's work this example. It says, given this linear inequality, y is greater than or equal to negative 2x plus 9, determine which points satisfy. In the same way that with equations, you're going to have several points that satisfy an equation, inequalities work the exact same way. So to see which of these satisfy, we're simply going to plug them in to our linear inequality, plug in the x, plug in the y, and see does it form a true statement. So for y, it's greater than or equal to negative 2x plus 9. When we plug in 4 for y, is greater than or equal to negative 2 times x would be negative 14, negative 2 times 7 plus 9. And that gives us 4 is greater than or equal to negative 14 plus 9 is 5. Since that is a true statement, check, this one does. It does satisfy it. The second one, again, plugging it in the place of y, we're going to put our 3 is greater than or equal to negative 2 times negative 1 is a positive 2. When we add 2 plus 9, it gives us 3 is greater than or equal to, just bring your symbol down, 11. That is false, so therefore that one does not satisfy it. Then our last one, in place of y, we're putting negative 5 is greater than or equal to, negative 2 times 10 would be negative 20 plus 9. Negative 5 is greater than or equal to negative 20 plus 9 is negative 11. Now, be careful with this. Negative 5 and negative 11. Here's 0 on a number line. Here's negative 5, and here's negative 11. Is negative 5 greater than negative 11? Check, it is. So therefore, this point also satisfies it. Real world examples. The same way that linear equations had your real world examples, so does linear inequalities. It says John sells t-shirts. Plain t-shirts cost $5. Graphic t-shirts cost $7. In order to match his product cost, he must make at least. Now, here's where the inequality comes into play. Anytime you're dealing with at least, at most, those type of phrases indicate that you're dealing with an inequality instead of an equation, because it doesn't say he needs to make exactly 1,200. So plain t-shirts cost $5. So we're going to let X be the number of plain t-shirts we're going to have. Graphic t-shirts will let be our Y. So he's going to make he's making $5 for each plain t-shirt, plus he's making $7 for each graphic t-shirt. So 5X plus 7Y tells you the amount of money or his the amount of money he's going to make. In order to match his product cost, he must make at least $1,200. So the amount of money he's going to make, this amount right here has to be at least. It has to be either greater than or equal to $1,200. At least means it could be bigger or it could be equal. So therefore, there's your inequality. If he sells 150 plain t-shirts, so what they're going to do now is, okay, what about 150 plains and 60 graphics? Will that be able to cover cost? So what we're going to do is take our inequality. In the place of our X, which was the plain ones, we're plugging in 150. In the place of our Y, which was graphic, we're going to plug in 60. And we're going to see, does that give me a value at least 1,200? So it'd be 750 plus 420 is greater than or equal to 1,200. That'd be 1170 is greater than or equal to 1,200. So he's not going to make but 1170. So will it cover production costs? No, it will not. If he sells 90 graphics, what's the minimum number of plain t-shirts he must sell to break even? Okay, let's go back. 5x plus 7y. Now he wants to break even now. Greater than or equal to. So breaking even means it would equal 1,200. So we could actually change that greater than or equal to equals. If he sells 90 graphics, that's the y's, then how many x's would he have to sell in order to make $1,200? So therefore, 5x, this goes back to old stuff, plus 7 times 90 would be 630 equals 1,200. subtract the 630. That gives you 5x is equal to 570. When you divide by 5, that gives you 114. So he would have to sell at least 114 in order to break even. Okay, next up, we're going to graph some linear equalities. And if you're able to graph equations, and graphing linear equalities is actually going to be really simple. Here's your steps to graphing linear inequalities. Put the inequality in slope-intercept form. That's y equals mx plus b form. Be sure to flip the inequality if you multiply or divide by a negative. That's just a reminder that anytime you multiply both sides or divide both sides by a negative, you got to flip an inequality symbol over. We're going to graph the line. Now here's the only part that we might forget. We use dashed lines or dotted lines for these symbols, and we use solid lines for these symbols. The same way that, think about this, when you graphed x is greater than 3 on a number line. Here was 3, you did an open circle. Well, now for greater than or less than, instead of an open circle, we're doing a dotted line. When you had greater than or equal to, you did a closed circle. Instead of a closed circle now, we're doing a solid line. So the open circle and the dotted line means the same thing. The closed circle and the solid line means the same thing. We're going to shade above the line for these symbols, the bigger than, greater than symbols. So if it's greater, we're shading above. We're going to shade below for the two less than symbols. So here we go. Graphing the inequalities. Number one, this one's already in slope-intercept form. We have a slope of 2/3. We have a y-intercept of -1, so we plot our y-intercept. We rise 2 and run 3, and we continue doing that until we get, let's see, down 2, left 1, 2, 3, until we get enough to where we're comfortable graphing. If it's a greater than or a less than, we're going to do a dotted line. So I'm going to do a dotted line through all these points. Then we're simply going to shade. If it's a less than symbol, we shade below. If it's less than or equal to, we shade below. For either one of the greater thans, we're shading above. So since this is less than, below the line. Now here's, a lot of people have issues with below and above. If you had a ball and you drop it above the line, it would hit the line. That's this is a good way of thinking about this. So what about a point right here? What if a point was dropped? It would not hit the line. So if you're below the line, it's not going to hit it. If you're above the line, it would hit it. So which side do we shade below? Would be this side. So what does that mean? That means that any point on this side, any of these points over here, all the way up to right next to the line would be a solution to this. So that's what you're doing. You're shading where is the solution. Next one. Your y-intercept is 0. Your slope is -4/1. So you put your y-intercept as 0. Then you're going to rise 4, run 1. Make sure it's a negative slope. So let's go down 4 and right 1. That would be negative. Do it again. We do it again up here by going up 4 and left 1. And then we can do it again. Since it's or equal to, the same way that you would fill in the circle, it would be a closed circle. This is going to be a closed line. So it's going to be or equal to, close the line. Since it's greater than, we're going to shade above the line. So go to the line, draw an arrow up. This would be above. So there's the side you're going to shade. Next one, this one's in standard form. So let's get in a slope-intercept form. Step number 1, move the 5x over. It gives you 3y is less than or equal to -5x plus 12. Divide everything by 3. Gives you y is less than or equal to -5/3 x plus 4. Plot your 1, 2, 3 plus 4 on your y-axis. -5/3 is your slope, so go down 5 over 3. Make sure it's downhill. 1, 2, 3, 4, 5, 1, 2, 3. Continue doing that until you have enough points. Since it is or equal to, that's going to be a solid line. And we're going to shade below. So go to any point on your line and go below it. So that's the side we're going to shade on. So shade any on this side. So any point on this side is going to be a solution. You could take the same way on those first problems. You could take this point right here and plug it into this inequality, and it's going to be a true statement. this point plugged into this inequality is a true statement. So that's a good way to check yourself is if I took the point negative 1, 3 right here and I plug it into this, I should get a true statement. Number 4, move your x term over, and as you move it over, if you'd like to, go ahead and put negative 1x so that you have something to divide by. We're dividing by negative 6. Now here's where we might forget. If you multiply or divide by negative, this less than has to flip to greater than. Negative divided by negative is a positive. Also, negative divided by negative is a positive. So therefore, y is greater than 1/6x plus 2. Y-intercept is 2. Rise 1, run 1, 2, 3, 4, 5, 6. That's a positive slope. That's uphill. Down 1, 1, 2, 3, 4, 5, 6. So there's your line. Since it is greater than, we're going to dot the line and shade above it. So let's dot the line. And we're going to shade above it, which means go to the line and draw an arrow above the line. So that's the side we're going to shade. So there's your solutions. So if I were to ask you now, is 0, 0 a solution to this equation? You would tell me no. Is 2, 2 a solution to this equation? You would tell me no. Is 0, 3 a solution to this equation? You would say yes, because it's on this side of the line. Number 5, move your x term. We now have 12y is greater than or equal to 9x turns to negative 9x. Divide everything by 12. Since 12 is not a negative, you do not flip it. You get y is greater than or equal to. Negative 9/12, negative divided by positive, reduce it, that's negative 3/4. Negative 60 divided by 12 is negative 5. So here's what you're graphing. Plot your y-intercept, 1, 2, 3, 4, 5. Negative 3/4 is your slope, so you're going to go down 3, 1, 2, 3, right 4, or up 3, 1, 2, 3, 1, 2, 3, left 4. So that's a negative slope, checks out. The or equal to tells you my line is going to be solid. I'll put another dot right there. So a solid line, there you go. And you're going to shade greater than it. So go to any dot on your line and ask yourself which way is up, and that would be this way. So that'd be the way that you're going to shade on that side. So is 0, 0 a solution? Yes. Is 1, 1 a solution? Yes. Is negative 1, negative 10 or something, whatever down here a solution? It would not be, because that would be on the wrong side of the line. Okay, a little bit different. Remember how to graph x equals negative 4. That's a vertical line. You would go 1, 2, 3, negative 4, and then you would draw that vertical line. So this one's a little bit different. This one is actually not quite as hard. It's a dotted line because there's no or equal to. Now, here's the confusion, though, is there's no above and below. So here's what you got to ask yourself. Do I shade values over here, or do I shade values over here? Well, which x values are less than negative 4? Is 0, that's an x value of 0, is that less than negative 4? Is 1 less than negative 4? Is 2 less than negative 4? The answer is no. Numbers less than negative 4 would be like negative 5, negative 6, negative 7. We're shading values on this side because that's the numbers that are less than negative 4. That's the x values, because x here and x here and x here are negative 5, negative 6, and negative 7. Those are the x values less than negative 4. Okay, word problem. Let me zoom out. It says Stephanie spends 10 cents per text message sent and 25 cents per picture message sent on her cell phone. Her monthly budget for messaging is $30. So she has to stay below 30. So the amount she spends is less than or equal to, she doesn't have to spend all of it, less than or equal to 30. Write a linear inequality. So text messages, we'll let be our x's. Picture messages, we're going to let be our y's. So she's going to pay 10 cents for every x, plus she's going to pay 25 cents for every y. So that's going to be the total money right there that she spends. The amount of money that she spends must be less than or equal to $30. Using your graph, then graph. We haven't graphed yet. Okay, let me remind you of a really good way of graphing this. Instead of getting it in slope intercept form and all that, what I would do is use my intercepts. Anytime you're in standard form, use your x-intercept and your y-intercept, and this will give us a great opportunity to review that. Find your x-intercept and find your y-intercept of this graph, And let's use it to graph this line. So the way we're going to do that, to find an x-intercept, we're going to, if you don't remember, we're going to plug in 0 for y. Now what we're graphing, we're graphing the line first. The actual line is 0.10x plus 0.25y equals 30. So we're going to graph that line. To find my x-intercept, plug in 0 for y, so that'd be 0.10x equals 30. We're then going to divide by 0.10, mark it out, and you get x is equal to 300. Same thing for your y-intercept. To find your y-intercept, you plug in 0 for x. So that's going to be 0.10 times 0, which goes away. Gives you 0.25y equals 30. Divide by 0.25, and you get y is equal to 120. Now we're going to have to do something with the scale on our x-axis and our y-axis. Reminder that our x-axis is, let's see, x's are the number of text messages, y's are the number of picture messages she can send. So in order to get this 300 to fit, let's see, what can we do with our x-axis? Let's let each box count 10. So this would be 10, this would be 20. I'm just going to label it like this, 30. This would be 40, 50, 60, and so on and so forth. And let's do the same thing for the y-axis. This would be 10, 20, 30, 40, and I think then we'll be able to fit this on here. So our x-intercept is 300. So that'd be, and I don't think that's going to fit still. So let's go back and let's change our scale again. Let's let each box count 20, and then let's see, we need 15 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. So this 15th box would be 300. So we're letting each one count 20. So this would be 280, 260, and so on and so forth. So every box counts 20, and we'll do that on both directions. Each box is 20. So my x-intercept is 300, so I'm going to put a dot at the 300. My y-intercept is 120, so that's going to be 20, 40, 60, 80, 100, 120. And we're going to draw our line. Let me draw as good of a line as I can. And that looked like a pretty good one there. And the reason I had to draw as good of a line as I could is because I've got to be careful about which points are above and below it now. So that was the line y, let's see, 0.10x plus 0.25y equals 30. So there we have it. Now we say on B part, using the graph, well, we never shaded. So we've got to figure out, do I shade above and I shade below? Now this one, since it's not in slope intercept form, I want to show you another way to figure out which way to shade. You can actually pick a point. You can pick the point 1, 1. And you could ask yourself, is 1, 1 a solution to this inequality? When I plug in 1 for x and plug in 1 for y, it gives me 0.10 plus 0.25 is less than or equal to 30. Is that a true statement? Sure, that's 35 cents. Is that less than $30? Yeah, so that would be a solution. If that is a solution, then everything on this side would be a solution, okay? So the next part says, using your graph, give 2 possible combinations of text and picture messages that she can send to stay within her budget. So actually anything on this side would stay within her budget. So let's get as close, because we want to send as many as we possibly can. So let's get as close as we can. Let's pick a point. Let me change colors. Let's pick a point right here. That one would be a combination, or way over here, this would be a combination. Remember that we let each box count 20, so that'd be 20, 40, 60, that'd be 80 X's, and 20, 40, 60, 80 Y's. So she could actually send 80 text and 80 pictures, and she's within budget. Or she could do this. If she likes to send more text than pictures, that'd be 20, 40, 60, 80, 100, 120, 140, 160, 180, 220. She could send 220 text, and that would be 20 Ys, which would be 20 pictures. So either one of those points would stay within budget. Again, anything below this line stays within budget. And you can check that by plugging into our original inequality. The next one, and the last one. Scott makes $12 per hour babysitting, $8 per hour working at the grocery store. He needs to make at least $600 to buy a new computer. Write an inequality. So babysitting will be our X. We will let working at the grocery store be our Y's. So he makes $12 per hour babysitting. So for X would be your hours, 1 hour, $12, 2 hours, 24, and so on and so forth. Plus, he makes $8 per hour working at the grocery store. So 8Ys, again, where Y is the number of hours he spends at the grocery store, is going to be the money he makes there. So the total amount of money he needs to make would be this, or that's how much he makes, and he needs to make at least, which would be greater than or equal to 600 to be fine, so we can throw in or equal to. He needs to make at least 600. Now, I think, and I highly recommend this, I think this is going to be a reducible inequality. Everything's divisible by 4, so I could actually do 3x plus 2y is greater than or equal to 150. You can clean it up some before you change it. And let's go ahead, since we didn't on the last one, let's change this one to slope-intercept form. That'd be 2y is greater than or equal to, let's move our 3x over, leave the 150. We're going to now divide by 2, and it gives me y is greater than or equal to negative 3 halves x plus 75. So in order to get this to fit, we're going to need a 75 on our y-axis, and we got to be really careful when we're graphing this, and I'll show you why in just a second. I think, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think if we let each box count 5, 5, 10, 15, 20, 25, you can do the counting there. 15 times 5 is 75, so my highest point right here would be 75, so it works out great. So my y-intercept is 75, but here's what you've got to be cautious of. If you don't let each box count 5 over here as well, if you don't keep that same scale, then it's going to be tough to count your slope. Because negative 3 halves, you need to go down 3 and over 2. And you got to be careful because each box counts 5, not 3. Or excuse me, or not 1. So going down 3 and over 2, if the scale is not the same, you can't just go down 3 boxes and over 2 boxes. But since the scale here, 5 is the y and 5 is also the x's, we can go down 3 and over 2. That'll be fine. Down 3 and over 2, and continue doing that on, and then connect your dots with a line. Okay, there we have the line. Since this is greater than or equal to, though, oops, let me change back to my other one. Since we have greater than or equal to, that means I'm going to shade above the line. So that means at any point on this side, and that makes sense because he wants to make more than this amount of money. So that'd be above the line. So it says using the graph, again, we're going to give 2 possible combinations for the hours that he can work. So again, anything on this side, that's your shaded side, is going to be a solution. Now he doesn't want to work just entirely over, so let's see, let's try to get something in the middle. So here's a point that would satisfy the inequality, and maybe this point right here would satisfy the inequality. Each box counts 5. So we have your x-axis was the amount of babysitting he's going to do. So let's see, we could let x be 5, 10, 15, 20, 25, 30, 35, 40, 45. So this would be the point 45, comma, 10, because each box counts 10. So he could work 45 hours babysitting and 10 hours at the grocery store, or this point right here is represented by, that would be 5, 10, 15, 20, 25 hours babysitting, and then 5, 10, 15, 20, 25, 30, 35, 40 hours at the grocery store. So either one of those combinations would give him enough money.